Right here we have a problem from chapter 4.5, question number 46, which is linear approximation question. So part A is to write an equation of the line that represents the linear approximation to the following function at A. Before we do anything, we need a linear approximation formula, which is L of x is equal f of A plus derivative of A times x minus A. Now, what we need to do is find the derivative of the original function. So derivative respect to x is equal secant squared of x. Now when we have this, what we want to do is use this value at a equals 0, and plug it in the linear approximation formula. So that will be L of x is equal f of 0 plus derivative of 0 times x minus 0. So we can see for each value of a, we have 0. When we solve for this, so f, which is original function tan of 0 plus derivative of original function is secant squared. So secant squared of 0 times x minus 0 is just x. So when we solve for this, tan of 0 is 0 plus secant squared of 0, we know it's 1 times x. So the answer is x for here. So we can write the linear approximation function at x is equal x. That's part A. Part B says graph the function and the linear approximation at A. So the easiest way to do this is by using the graphing utility calculator. How we do that? So first we plug in the original function, which is tan of x. Next we plug in the linear approximation formula, which is answer of linear approximation formula, which is x. When we press trace, this is what we get. So as you can see, this line in here, that's the value of tan of x, and this straight line is the x, which is 45 degrees in here. That's part B. Part C, it says use the linear approximation to estimate the given quantity. So how do we do that? At the beginning of the question we were given tan of 3 degrees. First, what we want to do is convert these degrees to radians. So 3 degrees is equal 3 degrees times pi over 180 degrees. So we can cancel the degrees, and what we get is 1 over 60 pi. Now what we want to do is set this value to x, which is this x in here. So x is equal 1 over 60 pi. Next, we know from part A the linear approximation is L of x is equal to x, which we can see in here. So we want to plug in this x value in here. So L of pi over 60 is equal pi over 60. So when we do that, pi divided by 60, which is approximately 0.052359, and so on. So we want to write as much decimals because this is approximated value. 0.052359. So I rounded up to 7 decimal places. And in here we're done with part C. Part D, it says compute the percent error in the approximation. So the way we do that, we substitute x, which we know it's equal to pi over 60, into f of x, into original function. Original function was f of x equal tan of x. So f of pi over 60 is equal 10 of pi divided by 60. When we solve for this, we get value of 0.524078. I'm sorry, I missed one decimal in here, which is 0.0524078. So this is the exact value of the approximation. So how do we compute the error? So percent error is equal to absolute value of approximated value minus exact divided by exact value times 100. So we know that's 0.0523599 minus 0.0524078 divided by 0.0524078 times 100. When we calculate this, we get 0.0914% error. So as you can see in here, this is the error.